Okay, so before we get started, I want to do a quick poll. How many of you have ever, either now or maybe in the past, maybe when you were a kid, ever read much science fiction? Oh, good. That's so helpful. We're going to look into the longer-term future today. And one thing that I've found as I track technology over these few decades is science fiction's coming true. Have you guys noticed that? It's coming true more and more. So the way to figure out what's going to happen in technology and science in technology is if you can remember the science fiction you read, think of that set of stuff, and think about, okay, how much of that stuff fits with current science, and the intersection of those two sets is what's going to happen. And if you think about the past 30 years, you've seen it coming. And we're gonna do a quick tour of that. It's sort of a whirlwind tour, or you can think of it as like a taster's menu of technology. So first we're gonna do nanotechnology, and it helps to understand the size of things. So we've got some sizes here for you to understand. Each of these is a factor of 1,000 difference. Each of these is 100,000 difference. And these are 1,000,000 difference. So we've got a nanoparticle, like nanotechnology, a million times bigger is an ant, and 1,000,000 times bigger would be the Indianapolis Motor Speedway. So that's a factor of 1,000,000. And so you realize, okay, when you get down to the nanoscale, it's really, really small. So what is nanotechnology? Here's the government definition. We don't need to use that. All we need to do is think about, okay, this stuff is down at the molecular level. These things come in different shapes and different sizes. It makes a huge difference what shape and size they are. And you notice these three terms. Steve mentioned that the term open source software. We adopted that term because the old term was confusing. The term nanotechnology is too general, so I decided, well, let's call them nano chunks, nano blobs, and nano shapes, and then that will help people understand them better. And it helps me, so I thought I'd throw that out there. Feel free to use those. So here's a shape. This is called Buckminster fullerene, after Bucky Fuller. And you notice this is the same shape as a soccer ball. Now, why would that be useful? You can imagine if you had these things, they would roll, right? I mean, it's a ball, just like a soccer ball, it would roll. Well, they use this shape of nanoparticle as a lubrication, right? Down at this scale, something that's round is like a lubrication. So this, you can see this, the red shape, that's a long tube. That's a carbon nanotube, and those of you who are in technology probably have heard of these. They're super strong. You can make really strong stuff out of this. And one thing I've learned about this area is there's a whole lot more high tech here than I had realized. So when I say carbon nanotube, I know some of you are understanding this, so that's great. Now, so what do you use this stuff for? That's what's important. That's what's important to the EconAlliance. Can we use this stuff here, maybe, even in the North County? Well, we talked about clean energy for this area. I heard they're shutting down the nuclear plant at some point, so we're going to have to do this, right? These are platinum nanoballs, and if you put light on them, you can release hydrogen from water. Clean, right? That's clean energy. You don't get much cleaner than hydrogen, right? Here's some more nanotechnology. These are semiconductor nanoparticles. This is to tune specific light frequencies for solar cells. You know, up until very recently, I was still kind of skeptical on solar. I thought, you know, it's all well and good to have power when the sun is out, but we need power all the time. This is not going to work. Just lately, I've become convinced, okay, the technology, you can store this stuff now, right? If only we could store it, solar becomes totally doable. And the technology is very close or almost here. So, you know, it used to be we needed the nuclear. Maybe we really don't anymore. And I was skeptical up until very recently on this. Here's another nanotechnology that's relevant for energy. These are molecular sieves. You can see these molecules are kind of sneaking through this lattice structure. It's like a sieve. It's like it's being sifted. The pores are letting aluminum ions through, and these are catalysts for oil refinement. So whenever you see that word catalyst, this is something that saves energy. Saving energy is clean, right? We always want that. So if any time you can get a catalyst for anything, it's a good thing. Here's another nanotechnology. Again, this is for storing hydrogen, right? Hydrogen's clean energy, right? But there's a problem, right? You know the problem with hydrogen, it blows up, right? That's the problem. So you got to store it safely. It's critical. So this is one way to do that. What else do we want to do? Well, we want health. We all want health. What do we want to get rid of? Cancer. We always want to get rid of cancer. One big area that nanotechnology is being deployed into is cancer detection, imaging, and treatment. And the people doing this work, lots of money's going into it, a lot of federal dollars. Great work's being done, and I think within our lifetimes, cancer will be manageable. You never can use the term cure. The researchers hate it when you say cure. Never say cure. So we say we'll manage it. We're going to manage this thing we're going to get rid of it. That's the goal. So they're making good progress on cancer, and that's good news for all of us. Another energy application, one of my favorites. Remember I said catalysts are always a good thing. If you look in the upper right there, this is an atomically precise catalyst that can take CO2 in the upper left. You combine it with the catalyst, you get methanol, which is a fuel, right? So if only CO2 is there's too much in the atmosphere, right? This is the whole thing we keep hearing about, the climate change, the global warming. If only there was a way to get it out of the atmosphere. Well, how about if we could get it out of the atmosphere and turn it back into a fuel again? That's what catalysts can do for us. So another application of nanotechnology that's coming very soon is filtration. At first, it sounds kind of boring, but I don't know about you guys down here, but up where I am, we have a water problem. There's not enough clean water, right? Either the water's got some kind of contamination in it, or it's got salt in it, or there's just not enough, whatever. With these atomically precise membranes, you can do super cheap filtration and get clean water back. So something we have to do, and something that's coming fast. I know that company that's working on this, they've gotten grants to do this kind of research, and it's coming along fast. In fact, they're signing contracts with, I think, folks down here, with some of the water companies down here to actually deliver this water. So these are, the structure that I've been talking about are atomically precise. Every atom is in a designed location. This is not something humans have ever been able to do before. Mother Nature can do it, right? DNA is that way. It's atomically precise. But humans have never been able to do this until now. This is a new ability. So let's look into the future. Now we're getting into the science fiction. This stuff I've been talking about up till now is coming soon, pretty hardcore stuff. Now we're going to do a little science fiction for you and look farther out. But this is useful. For some of you, it's going to be during your working lifetime. For some of you, it's stuff your kids should know about. So it's useful to know this stuff. So those of you who work with computers know down at the computer level, at the chip level, it's all ones and zeros, right? And every 1 and 0 has to be in the exact same location. Same thing, that's the goal for nanotechnology, is to get all the atoms exactly where we want them. We are so far away from that now, but that's the goal, and we're getting closer. This is what we mean when we say digital style control. We want total control of these atoms. Atoms are harder than bits, though. They come in more flavors, and they're very picky about how you connect them up. They're like herding cats, if you've heard that term. I'm sure you have. It's like herding cats to get the atoms to go where you want. They're harder. So what would a technological revolution look like? There's enough gray hair in the audience. Mine's covered up, but I can see. I know a lot of that's true for some of you also. Many of you have already seen one technological revolution. Many of you can remember when you didn't have a personal computer. You didn't have a computer at home, right? It's not that long ago. I think I got my first computer in '81. right? Before that, you had no computer in the home. And to go from that day to where we are today, that's what a technological revolution looked like. It takes a while, right? But to some extent, I mean, the web is like, to me, a blink of the eye. I mean, that was only like 93 when that started, right? So that came really fast. That's a technological revolution. What we're going to look at is what happens if you get that kind of technological revolution, not in information, which is what the whole internet was, but in physical stuff, atoms and molecules. So those of you who remember any chemistry, even high school chemistry, if you look at this, you might go, I never saw anything like that before. I don't see how you would make that. And the answer to that is, you're right. We can't make this now. This is like a machine part, right? It's very regular. It's cylindrical. It should look like a machine because it's a machine part. Here are some gears. Now, these are designs, okay? These have not been built yet. We use chemistry software to do these designs, and the next step is figuring out how to build them. But the goal is to make machine parts atomically precise all the way down so that every atom is in the correct location. This is from NASA. So down this thing at the bottom right, we're going to build it. So watch, I'm going to see if I can make this work. Here it comes in. There, it's transferring. It's going away. Now comes another part. Here comes in. It's transferring, and there, pulling apart, and it's pulling away. So that's, if you want to build things with every atom in a specific location, it's like a little robot arm has to come in, right? You have positional control. Chemistry doesn't work like that. Today's chemistry, it's all in like solution. They're all bouncing around. There's no positional control in chemistry today, but this is the goal. Here comes another one in, and transferred and gone. So this is, think of it as like robotics, but down at the molecular scale, right? These are like little robot arms. So here's some more pictures. These are machine parts that have been designed but not built yet. Here's another one. Those of you who are mechanically oriented, this is a universal joint, right? These are used at the macro scale. They're going to be just as useful at the nanoscale once we can build them. Here's another universal joint. So you can do sorting. I'm going to zip through this. So what they're doing here is they're basically controlling that little red, blue, and red molecule to control it completely. Here's another design for a filter, right? If you want to have atoms in one place and not the other, you need a filter. Keep them on one side, don't let them go on the other side. Here's a design for that. You can see this is looking pretty complicated, right? This is not going to be easy to build. That's going to be hard to build. But we'll do it someday. Unfortunately, I can't give you a date. If I could give you a date, I would invest the right way and become, the next Bill Gates, right? So unfortunately, I'm not that good. And finally here, this is a planetary gear. Again, the mechanically oriented around you, you've heard of planetary gears. These are useful devices at the macro scale. We'll make them at the nanoscale also. So this is what's going to be coming. What good will it be, right? Especially those of you who maybe are not so technical, it's like, okay, that's great, so what? What's going to be delivered to me? Or from an economic perspective, from the North County perspective, how does this affect our business opportunities? Okay, let's look at 3 examples: computers, space, and health. Everybody should be interested in at least one there, right? We all have this health thing going on. Here's a quote: looking at computers, millions or billions of times more energy efficient computing from this. So if you look here, flops is speed. So with molecular computing, the speed is much higher, the watts is the power is much lower, and the dollars, look at those dollars, right? Huge difference on dollars. So let's look at space. This one, every time I hear this from my nanotechnology space experts, I have trouble believing it, and I've often had to go back to them and say, are you sure about those numbers? And they say, yes, we're sure. So I'm going to tell you this stuff. You can have the same reaction. Okay, so you've all been watching space launches for a long time. There's these big rockets that go up, and they don't deliver all that much payload to space because most of what they're lifting is often fuel, right? And for every pound of fuel they lift, they have to use more fuel to lift that fuel, and it's like a vicious circle. What if we could get a virtuous circle going the other way, where you reduce the weight of the vehicle so you can reduce the weight of the fuel, so you can reduce the weight of the fuel that lifts that fuel and lower the weight of everything? What do you end up with when you take that virtuous cycle and say, what if we could use super strong materials to make this, to make a launch vehicle? Here's what you get. The mass of a vehicle that could lift, say, 4 passengers and their luggage, they always emphasize that to me, I'm not sure why, 4 people with their luggage to space would be about the same as the mass of this pickup truck. So, I mean, we're all used to seeing launches like the one on the left, right? That's a space launch. It's a gigantic vehicle, and what that delivers is not that much. It's not going to be like that. If you have these super strong nanotechnology materials that you make your launch vehicle out of, the weight, they're so strong that the vehicle can be very, very low in mass. It's hard to believe, right? I always find this hard to believe, but I've gone back many times now, and they assure me this is correct. So I'm going to represent that to you. You can be boggled now. Remember I said technological revolution? If I had said to you, I mean, you all have a smartphone, right? If I had said to you, some of you who can remember back before you had a personal computer at all, and said to you, oh, well, you're going to have a supercomputer in your pocket. It's going to have access to all the information in the world. You'd say, I was crazy, right? But it happened, and it happened pretty fast, really, by historical standards. So I'm telling you now, here's another one that's coming, you know. Here's one. Here's some science fiction for you. I saw this as a title of a research article in August. Thought-controlled nanoscale robots in a living host. What? Really? Yes, apparently so. It was not in a human host, you notice. They don't say they put these in people. They put them in some kind of an insect, which is a good place to start if you're going to do this with people eventually. Start with insects. So what they did is they made, I'm not going to have you, don't read this, please, don't read this. But what it says here is mechanically actuating DNA origami robots tethered to metal nanoparticles, and they activate them by something by having the insect think something. Okay, science fiction. So what would this be about? For practical purposes, if you were to have, say, a human application, what would it be? Probably something medical. Maybe some kind of medication that gets into the brain, and when some kind of abnormal brain state comes along, maybe some kind of epileptic seizure or depression, I don't know what, something we don't like, the medication will be activated by your thought patterns alone. Talk about science fiction. Really wild stuff, but this has already been done. This has already been done in the lab with an insect model. So it's only a matter of time, right? We're going to see this in our lifetimes, I believe. And what's left? Well, we have 2 people here. One is healthy. The other one, we would say, well, maybe she's healthy for her age. She's not healthy, right? She has a serious aging problem. Aging it's a physical condition. It's a medical change that our bodies undergo, and it's going to be accessible to treatment. Great progress is being made biologically. Additional progress will be made with nanotechnology. And aging, it's hard to put a date on when that's going to happen. Aging is a hard problem. But it's being tackled very seriously. Those of you who track this know that there's big money going into this now. So when is this going to happen? I don't know. You know, people talk about our children's generation. I'm not sure when this is going to happen, but it's going to happen. Aging is going to fall. So that's nanotechnology. I wanted to kind of give you a whirlwind tour of that. Now, in the title of the talk, we promised you 3 technologies. We don't have time to do 3 in a heavy perspective, but we're going to do very high-level bit on the other 2. So what do we have? We promised you biotechnology. So here, if you're interested in, how many of you have heard about CRISPR? CRISPR? Okay, not so many. There's going to be a TV show about CRISPR. It's that dramatic. They've decided we're going to do a TV show about it. It's a new genetic engineering technology. Now, you've probably been hearing about genetic engineering for decades. I have. I was in high school and we had a debate, should humans be genetically engineered? So it goes way back. There's nothing new about genetic engineering. What's new is CRISPR makes it much, 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 much easier to do. Much easier. And much more targeted. So this is, suddenly, so there's been like this sudden spike in progress in genetic engineering. So all these science fiction-y things you've been hearing about for a long time that never happened, now they're going to happen. They're going to happen. So there's a list here, a number of things. Some have already happened, some are just, they could happen soon. But I just want to draw your attention to the second last one, which says edit humans. And that's what we debated back when I was in high school. I was on the pro side. I was assigned to be on the pro side, so I argued for it. It doesn't matter now what I argued. It's going to happen. And if it doesn't happen here, it's going to happen in China, for sure. Okay? So this is yet another science fiction thing that you've been hearing about for decades, and now there's been a sudden breakthrough. It's a huge breakthrough. Sort of came out of nowhere. People were surprised. I was surprised. But here it is. It's coming really fast. So again, I think this is coming in our lifetime. The second one here, eliminate a patient's cancer, that was already done. They had an infant with leukemia. The child was dying. There was nothing they could do, so they got special approval. Okay, let's try something really wild. So they used this new technique to take some immune cells from a donor, do some radical changes, sent those cells into this infant, and boom, infant's okay now. So it doesn't take too many of those examples before people say, hey, we want to do this now. We want this for everybody who has leukemia, right? And that's the first step. And then it just spreads from there. So all that wild stuff you've been hearing about genetic engineering that had never happened, it's coming. It's coming. And last but not least, we promised you artificial intelligence. Okay, so I socialize with artificial intelligence people, and they actually are kind of concerned. I mean, this is happening faster and faster. I just yesterday read again about another breakthrough in artificial intelligence. You've all heard that, well, artificial intelligence doesn't generalize. This, you can teach it to do specific things like recognize a cat's face, but it won't generalize. Well, yesterday they announced, okay, we got generalized, we got it. Okay, what does that mean? Well, the main thing people are nervous about is employment, right? I mean, most of you are knowledge workers, right? You work, you write on computers. Most of you don't do a huge amount of physical labor. So we're knowledge workers here. Knowledge work can be automated if you have good artificial intelligence. And I don't know if you've seen the numbers. I bet a lot of you have seen the numbers of the percentage of jobs that are going to be automated out of existence in the next X amount of time. And it's a lot. It's a huge number. So even if it's none of us here, there's a huge number of people who are going to be affected. And what happens to those people, and how do they support their families? And I hang out with a lot of very free market oriented people, business folks like yourselves, who believe in the free market and are not necessarily into high taxes and all. I'm totally on board with all that. But a lot of them, those folks are going, we have a big problem here. Those the people who are being put out of work, they have to eat. There's no way around that, right? So these free market people are starting to talk about basic income. And I was shocked. I'm just letting you know that a lot of free market people are looking at this issue and saying, maybe they don't like it, but what they're saying is, well, we need some answer. It doesn't have to be basic income, but it needs to be, we need to look ahead and go, what are we going to do with all these folks who are going to be out of work? We know the truck drivers for sure, right? That's coming really fast. They've already done the first delivery with this automated truck. It was a beer load, right? And it worked fine last I heard. So the truck drivers are going really fast, but then lots of other people are going, right? I mean, even things like medical diagnostics are going to go really fast. So I don't have the answers. I'm just letting you folks know it's an issue, and it's something we have to address, because if we don't address it in a smart way, it will be addressed politically in a really stupid way. We can be we can be sure of that, right? We can be totally sure of that.
How do you stimulate the atoms to do what you want it to do? Is it through electrical stimulation, chemical stimulation? Like, how do you, I know you said they kind of bounce all around, but how do you control them at all?
The only way to control them is chemically.
Okay.
In fact, that's sort of what, it's almost a tautology, because if you're controlling atoms and molecules, your only choice is to use chemistry. I mean, you can call it molecular physics, you can call it different things, but it's basically chemistry, because that's how you sort of define it. Anything that works at that level and it involves moving atoms and molecules around and rebonding them, they call it chemistry. That's how you do it. Anything else? Oh, there's one. And there's one.
Same table.
Do you see any foreseeable hazards with nanotechnology?
I do. In the short term, when right now they're using things called nanoparticles, and they're not as well controlled as the later stuff will be. And those kinds of things could potentially have the type of hazards that any chemistry could have. And you know, I don't know, you guys should be, I don't know if, I was surprised when I learned this. Many people assume that when a new chemical is used in the United States, it must have gone through some kind of safety testing, and, you know, the fact is it doesn't. New chemicals are made all the time, they go out on the market and they're used, and there isn't really safety testing. Now, I'm not saying that that's wrong necessarily, but it's true not only for nanoparticles, but for all chemicals. So yeah, there can always be hazards. And the goal then is to move beyond this initial awkward stage where we are now and say, no, we want total control. Then we can really clean things up. I think we had one more, and then I think we have to stop. Yeah.
Yeah, my question is, for nanotechnology, at what point do we start looking at the safety of it from the standpoint that it's a physical element, and once you're programming very small things to be able to change virtually everything you want to change, at what point do you say that that's different from doing when you're doing machines or programs, that sort of thing? I mean, people who want to hack that sort of thing should be able to be hacking then everything physically.
Yeah. Yeah. So just to do an analogy and to show how important that is, many of you are aware that we have these, we have the Internet of Things now, which for quite a while my computer security friends were going, it's not the Internet of Things, it's going to be the botnet of things. It's going to be a hazard, because these things do not have proper computer security built into them. And now we've seen that starting, okay? So before you put any internet-connected devices into your home, which, you know, a lot of you are doing, you know, being able to open and close your doors using your smartphone, being able to control your house lights over the internet, these things do not have good computer security. And so you really need to think twice about that. I personally have done none of that. Okay, just a little word to the wise. So the problem is you have the exact same problem with any machine. The questioner is pointing out, hey, we have the same problem with nanotechnology. Absolutely. So even though we're looking for the ultimate physical control, that doesn't get you the ultimate computational control. You still have viruses and all these kinds of things. So if you want to do it right, you have to have excellent computer security. I know folks who've been working for decades to get excellent computer security in, and they cannot get people's attention. So it's going to take a total disaster before these folks are paid attention to, and we're not there yet. So it has to be a major disaster before this problem is solved, and you're absolutely right. So thank you. It's been a great audience, and I'd love to come back.